All right, guys. We had our first session last week, so this is what se- had our first session last week, looking at a bit of some Newton's laws. Um, I think I'll just quickly start on that. Guys, quickly look at this question. Let me give you 6 minutes. Get me all of these marks as quickly as possible. 7 minutes tops. Please, everybody, we start working now. 7 minutes tops, because I want you to quickly walk through. Then we'll look at um, Google sent me some questions. We'll look at them together. But this is basic, and I want everyone to be able to get me this without stressing. All right, I'll talk to you again in 6 minutes. Did you guys manage? Or was the time too short? All right, let me add 3 more minutes. Okay, Google, I added three for you. Once you are done, throw in your answers, please. Throw in your answer for acceleration once you're done. Kind of stuck. Yeah, I'm glad if I can get those responses. Taiba, Amira, Taiba, come on. Part two, what's your answer? All right, let's see quickly. A block of mass 2 kg is sliding down and inclined at an angle of 30 degrees to the horizontal as shown in the diagram. The coefficient of kinetic friction between the block and the plane is 0,2. How do we write coefficient of friction? Okay. K is equal to 0,20. Number one, define the term kinetic friction. Right. Kinetic. Once we say kinetic, it means the object is moving, right? So it is the force opposing object in motion. Body diagram. Gravity is always acting downwards no matter what. Object is moving down, so friction must be acting. Guys, your friction should be parallel to the plane. Friction and your normal force should be perpendicular to the marks, please. Be jealous about getting those 3 marks. Jealous about getting those 3 marks. Listen again to the characteristic of the forces. Fg is always acting down. Normal, 90 degrees. Calculate the acceleration of the block. Definitely we know we are using F net equals to ma. All right. Please make sure there are arrows on those lines of forces. It's a vector. Arrows. You are drawing lines, not lines is 0. You get. Calculate the acceleration of the block. What do we know? F net definitely is equal to m. The problem is, I've told you, don't work with this diagram the way it is. All right, so this diagram needs to be redrawn. And if we draw it, we have our normal Fg perpendicular. Friction was acting upwards. And Fg parallel must be parallel towards the surface. Look, guys, here is your surface. Please, if our free body diagram is wrong, we're going to have a big problem with physics. Right, this is the one we use in calculating. This is Fg parallel, Fg perpendicular, normal. And what is the formula for Fg perpendicular? Mg cos. We must know these formulas quickly. 1 mg sine. Object is moving downwards. So let's take the down motion as positive. Guys, you do all of this before you start calculating. Life becomes very easy. So what do we know? F net is equal to MA. Fg parallel plus negative friction. But I noticed that we don't have friction in this question. That's why it's 5 marks. The examiner did not give us friction. Right? So what do we know? Let's find friction first. Friction equals to mu Kn. But what is my N? You go back to the diagram, the force that is opposing or opposite that and that. That's why, guys, you cannot play with your free body. Once your free body is wrong, forget about Newton's laws. If we cannot draw free body and interpret it. So this is mu K mg cos theta. For me, I'll just throw everything in so that I don't have cos to round off any figure. So it's minus Fk equals to Ma. What is this? Mg sine theta minus mu k mg cos theta equals to what? Ma. They give us the mass of the object. They give us the mass 2 kg. But it is I want to work without the mass. Guys, in case the mass was not given, what would you do? Can you see? What I would do is, just in case I'm not given mass, don't think that the question is now wrong. Do you notice what I'm doing? Actually what? Factorizing what's common. I'm doing this for you to see that even without the mass, I can still get an answer. Divide both sides by m. So what do we have? 9,8 sine 30 minus 0,2 divided by 9,8 multiplied by cos 30 equals to a. So all of this. So there are certain questions that do not have masses. Please, you saw what I did. You just continue. Don't get stuck because you don't have a mass. Sine 30. Oh, I need to close. 8 cos what? 30. Why am I getting a different answer from you guys? Am I missing something? Mg sine theta, 9,8 sine 30. Yes, let me do it again. Right? Minus the coefficient of kinetic friction. 8 multiplied by cos what? 30. Hey, must have pressed something wrong. 3,20. That's per second what? Squared. So guys, I'm glad I went this route to show you that even if I don't have mass, I can still get my answer. And I hope it makes sense so that you don't get stuck saying you don't have mass. Are we okay, guys? Those of you that got stuck? All right, Divine, you added applied force. Yes? Sorry? The mass. I don't need it. That's what I'm saying. I'm showing you that because there are certain questions where the examiner would not even give you the mass. So don't say that, oh, there's no mass, this question is wrong, la la la. Is that okay? So you can see what I did. I really did not need the mass. The object was not pushed. Okay? For you to have applied force, the object must be pushed. Divine. It says the object, a block is sliding down. No one is pushing the object. The object can slide down. If you take your book now and put your pen, what's going to happen? The pen is going to slide down. And you put, whenever you see a force is applied, an object is pushed, an object is pulled, that's when we deal with applied force. All right. So guys, that's very important. Yeah, quickly try this for me. Try this for me. I'll give you, here I'll just give you 4 minutes. I don't want to give you more than 4. So maximum for you to read and see what's going on. 5. Read and I want to see your approach. How did you guys find this question? How are you finding this question? Give me a quick response. What's going on? Saiba, it loves you, hey? I promise you. This question loves you. Part two? You're confused. Last thing I want to do. Amara, why are you thumbs down for my question? No, man, you can't do that to me. Check Seatley as well. No, 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 no. See her? I agree. Oh, you got tears. Do you want me to send tissue to you? Okay. Tissue coming right up. Batu, this question smacked you left, right, and center. All right, Nasia, I'm sending a box of tissue. Okay. Get it shortly. All right, let's look at this. If two adjacent buildings of the same size, the two walls nearest each other are 7 meters apart, and the walls furthest from each other are 35 meters apart, as the diagram below illustrates. I think that's clear enough, right? 7 and 35. Use an appropriate calculation to show that the gravitational force, now we are using Newton's law of universal what? Gravitation. So that the two inner walls exert a force on each other, which is 20 than that of the outer walls. Fg inner is equal to 25 times Fg out. The first thing I need to write, guys, is to write my formula. What's my formula? Universal gravitation. Please be able to state that law. G m1 m2 over r squared. Let's do the inner walls first. All right, F, let's call it inner, all right, is equal to G. Now, it says the walls are of the same mass. Is that okay? So let's use M. M. How far are the walls from each other? The inner walls. 7. So this gives me what? 7 what? Squared. Is that okay? Okay, guys, we are not solving this. Please don't try to solve. Okay? 49. Now, let's do the same thing for the outer walls. F, okay, let's say outer walls. Outer walls. We're doing the exact same story. F outer equals to G. Again, it's going to be MM because the walls are the same. But what's the distance now? 35. All right, so it's 35 what? Squared. What will this be? F outer is equal to GM squared. Now, when you see questions like this, guys, you are going to try to write them in terms of each other. What do I mean? Okay, I want us to be smart. What is 35? 35 is what? 7 times 5. Oh, okay, it's fine. It's fine. Let's find GM squared. I want to think like you. 9F inner. Do we agree? Cross multiplying. Let's cross multiply here. What do we have? GM squared. What is 35 squared? Give me, because this is what you'll be tempted to do. So I want to go your temptation route. 1,000? 1, 2, 2, 5. F what? Outer. Now, do you notice that both of them are equal to GM squared? So can we equate them and solve simultaneously? Therefore, you see, GM squared is equal to that, right? So what is GM squared here? It is this. What is GM squared? GM squared is what? 49F inner. What is this? What is GM squared? I'm going to put that in to say, therefore, 49 F inner is equal to what? 1225 F what? Outer. What is F inner going to be? Divide. Let's divide. 1225 over 49 F outer walls. What's your answer? 5 F F inner, FG inner is 20. That makes sense? Please let me know if we got that. All right, can you see how easy it was? Taiba. At least now you have an idea that, okay, if I see a question like this is what I should do. This is why exposing yourself to a lot of past papers is very good. So please, textbook questions and start working real past papers. All right, awesome. Great job, guys. Job. Let's go look at the next question. All right, can we move on? Awesome. All right. Google your question, but this looks like the one we did, so I don't know if. But let's see. Let's see. A car of mass 350 kg is accelerated up along a straight hill by a net force. Guys, learn to write what you are given. Now, we are told that there's a net force. F net is equal to what? 370 Newton. The net force is parallel to the hill, which makes an angle of 35. So I know my theta 35 degrees. All right, the coefficient of kinetic friction, 0.21. Draw a free body diagram with labels of all the forces. Everybody quickly draw. Let's draw. It's similar, only that in this one there's an additional force. Let's quickly. Okay. All right, guys, here is what my force would look like. Your normal part, I want you to get this. That is wrong. We're going to be wrong. Your normal must be, you see, that's what your normal should be. Gravity is always acting where? Down. An applied force, and we are told it is part. force, and that is force. Very important how we draw those forces. Parallel to the gravities acting downwards and is perpendicular to the sky. Right. Guys, do you think we can get the acceleration of upwards? Now, remember what we said. Don't work with this diagram. We need to calculate. What do we need to do? We need to redraw. And how do we redraw the diagram? So it's routine now. Normal is that way. Let's use white. Normal is that way. Once you draw normal, remember what your surface is. The surface FG parallel. It means it must be parallel. FG parallel. What's the formula? mg sine. Just do that quickly. Right, the object is being pulled up, force applied. Of motion. All right. By the way, we know this as three. What is the mass? Mass is 350. Okay, the object is moving up, right? So I'll take up as positive, negative, and negative. All right. I see. I don't know what the examiner is asking us to calculate friction. Calculate the magnitude of the acceleration of car. Okay. Oh, guys, I'm wrong when I said 370. Because the examiner says the net force. All right, that's why reading is key. That F net is equal to what? MA. They said the net force is 370. That's again. Mass is what? 350. What is 8? 37 over 35. 1 comma. Dividing both sides by both sides by 350. Next question says calculate friction. Fk equals to mu k. Go back to your diagram and check quickly. Mk, which force is opposite friction? Okay. Mg, normal. Force 35, I think. Calculator, let me just confirm what you are writing. Start in a calculator and remove 1 times 350 plus 35. We close 500 90. Okay, this is looking at 590,0. 590. Let's just confirm. Please, everybody confirm for me. Did I type everything correctly? Are you getting the same answer? Okay. And the last question there says we should calculate the applied force. Look at your diagram. All right. Applied force means, or if we say F net means sum of all the forces, which is what? Force applied plus minus Fg parallel. 370. We do applied, but we know friction. 590,04 minus, what is Fg parallel? Mg sine theta. What is M? 350 times 9,8 sine 35. All right, so 370 equals to 4. Right? Okay, let's see what this would give us. 590,04, right? Minus 350 35. Just enjoy physics. 1377,327. I don't want to run quickly. So it's 1377,327. 1377,327. I then bring that over. It becomes what? Positive. So what is your force applied going to be? We add 370 to that. That will give us 7 plus 7 is 4. 6 plus 1 is 7. All right. And we can round up completely. All right. Google, I hope that makes sense. Okay, guys, let's go do some electrostatics and electric circuit. Electrostatic and electric circuit. Taiba, I hope you're getting set. So it's all about free body what? Diagram. You get that right and we are good. All right, again, here is this question. And I remember telling you something that you should do about a graph. All right, it says, a class of grade 11 learners want to investigate the relationship between the inverse of electrostatic force and the distance between two identical charges. Let me do this so that it's very clear for you at home. Don't be angry. I also got the picture like that, but let's see what we can do. Right, let's see what we can do to this. There are two questions I'm going to break down. Right, why is it not cutting? Right, I don't know. In for that. There we go. Hi. What is wrong with it, Sitley? Right, I'm going back now, Sitley. Yeah? Mm. Okay, let's get a calculator. Let's get a calculator. Okay, wait. Comma 04 minus 350 times 9,8 935. Okay. Is this what you have? Yes. All right. I think I see what I see why I got my 377. I said 5904. I didn't consider the negative. All right. So this is correct. Thank you for bringing us back. That was a mistake there. It's negative 5904 minus that. So please let's correct that. All right. 2577,4072. Thank you. That's a very important point. 2577,4072. All right? And then you can add the 370 to it. 2577 557. All right. 2557,70. Comma what? 404. Is it 40? Are you sure? 4072. And if we add 350 to it, what are we getting? 29927,41. All right, thank you, Sidley. Beautiful observation. Guys, do we agree with this? I skipped the negative when I was doing that calculation there. Thank you so much. Awesome. All right, so let's get back to this. Now, guys, look, use the graph and write down the relationship between the distance. Please, the distance and the inverse. Always read this. It says the distance, all right, and the inverse of the force. Yes, this is the distance, and that's the inverse of the force. And you can see, if it's a straight line and it starts from 0, it means they are directly what? Proportional. So that's my first answer. Directly what? Proportional. That's the relationship between them. It's a straight line, all right? And number 2, determine the magnitude of each charge. This is very key. I taught you how to deal with graphs, guys. What do we have on the y? 1 over f. What do we have on the x? R squared. So look at what I'm going to do. You're going to do 2 things quickly on the graph. This is 1 over f, and this is what? R squared. Let's try to find the gradient quickly. What is gradient? M is change in y over what? Change in x, which is basically 1 over f divided by what? R squared. Let's do simple maths. 1 over f times 1 over r squared, which is 1 over fr squared. This is gradient. Now, what's the formula for electrostatics? F equals to K, Q1, Q2 over r squared. Now, what you are trying to do is to get this formula to see if it exists from the main formula. Let's cross multiply. Fr squared is equal to what? K, Q1. Oh, check. But what is your gradient? Your gradient is 1 over. It means I can get Fr squared once I get my gradient. I can get the gradient of the graph, which is M, because I know that M is equal to 1 over. So let's go look for M on the graph. Gradient, y2 minus y1 over x2 minus x1 is something that we can get. Quickly write this down so when we go to the graph, we just get all the values once. So please, when you see a graph, this is one of the things you do. So now we are going to get the gradient of this graph. Let's go check. Gradient, already I know a point, 0 and 0. I know it's not very clear, guys. We'll reshare this question on the group, but I can pick that point because I see it's very easy to read. That is what? 8. And this is 0,6. And both of them come here, and that is 0 and 0. So our gradient is 8 minus 0 over what? 0,6 minus 0. Normal gradient. Y2 minus Y1. So 8 minus 0 over what? 0,6 minus 0, which is 1 over FR squared. Please give me an answer there. 8 divided by 0,6. 13, right, 13,33. So we're saying 13,33 equals to 1 over FR squared. What is FR squared? Guys, we can reciprocate this like we do under electricity. So 1 over 13,33 is FR squared over 1. You saw what I did? The denominator became the numerator. Whatever I do on the left, I also do on the right. Okay. So what is our FR squared? We know that FR squared equals to what? K, Q1, Q2. What is our FR squared? 1 over 13, what? 33. What is K? 9 times 10 to the power 9. We are told these charges are identical. So I'll come here and say what? Q squared. Now we can solve this. Okay, I'll go simple way. We cross multiply. 1 equals to 9 times 10 to the power 9 times 13 times 33, Q2. Can we divide both sides by that number? So Q squared becomes what? 1 over. I'm just doing this because so that you would do the maths very easily. And then what is Q? Grab a calculator, guys. Grab a calculator. Square root. 1 over 9 times 10 to the power 9 times 13,33. 89 times 10 to the power negative 6. 2,89 times 10 to the power negative 6 columns. Very important stuff, guys. Very, very important. I want to try something else. Excuse me. I want to try something else with you. Try something else. Let me know if this makes sense to you guys. Quickly, let me know if this solution makes sense to you. When you see a graph, what you do is look for the gradient of the graph. See, gradient is y over x, so 1 over f divided by r squared. 1 over f times 1 over r squared. So my gradient is 1 over fr squared. Then we went to the formula. F equals to KQ1 Q2 over R squared. Cross multiply, I see my FR squared. Then we got what we wanted. Let's try something else. Mind, and I want us to work with it. The second thing that we should try again, hopefully it works, but generally when you see a graph, generally when you see a graph, there are two things you must do. It's either you find the gradient or you multiply the axis, product of the axis, product of the axis. What do I mean? I'm going to multiply. Let's see what we are going to get. 1 over F times R squared. What is this giving us? R squared over F. The question now is this. Can we get this from the formula? What's our formula? F equals to what? K Q1 Q over what? R squared. This is over 1. But I want R squared over F. Now, I don't know if you see this, that there's no way you are going to get R squared over F here. Once you cross multiply, you are going to get what? FR squared. But we are looking for R squared over F. So this one is not working. Things we see on a graph quickly. For graphs, when you see a graph, number one, divide the axis to check y over x. If the formula exists, what are you looking for? You are looking for multiply the axis y times x. If the formula exists, you find the area. And number three, it's a straight line graph. If it's a straight line graph, we can simply try to rearrange. Let me try this. Y equals to mx plus c. I want to try this and see. I want to try this and see. Because this line is a straight line graph, right? Y equals to mx plus c. All right. What's our equation? F equals to what? K. Q1, Q2, bar R squared. Now, what on the y-axis? Please watch what I'm going to try to do. What's on the y? It is 1 over f. Okay, but here I have f over 1. Let's reciprocate it. What are we going to have? 1 over f equals to what? R squared over what? K, Q1, Q2. Okay, what's on the x? R squared. Now, if I can cover R squared, look at this, guys. I'm going to really cover it. I want you to tell me what you see. I'm going to cover my R squared. What do you see? 1 over K Q1 Q2. I hope it makes sense. All right. I see that I can write this as 1 over F equals to what? 1 over K Q1 Q2 R squared. Plus what? 0. Why am I adding 0? Y equals to what? Mx plus c. C is the y-intercept, and that's 0. What is your gradient if we compare these two? What is your gradient? So my y is that. My x is this. My y is that. So what is m? M equals to what? 1 over K Q1 Q2. What was our gradient earlier on? 13,33. So I could come here and then say, okay, all right. 13,33 equals to 1 over, what is K? 9 times 10 to the power 9 q squared. You are going to get the same answer. If you cross multiply, 1 will be equal to, I don't know if you remember this particular line. Got to the same line when we're working out our question. So guys, please, let's learn those physics. All right? Guys, are we okay? Everybody okay? Can we move? Right. I hope we are learning quickly and revising. It's making a lot of sense. All right. Then we have a second part of the question. We have a second part of the question. Let's see if we can quickly get that. Thank you, Google, for sending such questions. I love it when you guys are working and you just to do on the group. I know sometimes. All right, let's look at this. The diagram below, point B has a charge of -6 nanocoulombs and point A an unknown. A is 0.40 away from B. P is the point that is placed 0.15 meters from A. The net electric field we are given. All right. The net electric field at point B due to A and B. Please take note of where the electric field is. It says the net electric field at P, all right, is what? This, and it says to the left. It's important to know the directions as well. Is A positive? The first thing I know is this. A point charge P is positive. What were we told? B, right? Negative. We're given that. Whether it's positive or negative. Our focus, guys, is on P. They said the net due to P is to the left. All right. Let's forget about A. Since we are focusing on P, what's going to happen here? How is P going to move because of B? There are unlike charges, right? There's attraction. So P should be attracted towards what? Right, guys, our focus is on P. So we do that. That electric field. So this is E. Oh, it's now easy. We were told that the net is to the left. Net means after adding both of them. After adding both of them, the result should be to the left. But I already have one to the right. Please, I want you to listen to this. If I draw a force, let me use a highlighter. If I draw a force this way, what's going to happen? Both of them are to the right. It means the net is going to be to the right. I want the net to be to the left. So it means there must be a force that is greater than this one. Right? And this should be what? A must be greater than EB. that my answer can be towards the left. Now, what are we saying? We are saying P is also going to the left. What will make P go to the left? A has to be what? Okay, to attract. So our answer there is what? Negative. Please let me know if my explanation makes sense, guys. I need to get a feedback on this one. Says the net is to the left. One we know is pointing to the right. So we need a greater force to the left. And what is it that we pull P to the left? A must be negative. Draw an electric field pattern between A and B. Can I ask you to draw that, if you remember? A is negative, B is also what? Negative. What happens to like charges? Let me draw it to save time. Like charges will do what? They repel. Right? They repel each other. These lines must not touch each other, guys, please. Parallel to each other. Right. And one thing we know about the negative, charges are always moving into the negative. They are from the positive, but they move. Marks, I think. One for the direction of the arrows, one for the lines not touching each other, and shape of the whole thing. Negative and negative. 3 marks. Don't forget that. Let me answer the last one quickly. You can take pictures of this when I'm done, guys. Calculate the magnitude on charge A. I'm going to need this free body. Please, guys, once the examiner asks you for net, don't do it without a free body, please. You'll be killing yourself without a free body. Okay? We said this is E of B. Let's take right as positive. That's positive, and that's what? Negative. What do we know? E net. We add both of them together. EB plus negative what? EA. Net, therefore, is equal to what? EB minus EA. But we know our E net. We're given 6 times 10 to the power 5. To the left. 6 times 10 to the power 5. Left is negative. So negative 6 times 10 to the power 5. What is the formula for E? KQ over R squared. Right? KQ. So what would this be? KQB R squared minus KQA. It's just some lovely math here. Negative 6 times 10 to the power 5. 9 times 10 to the power 9. What is QB? Negative 6. But guys, we don't need the negative. 6 times 10 to the power negative 9. Why negative 9? Nano. And what's the distance between P and B? Lovely. This example is just very tricky. Our focus again is on P, right? What's the distance between B and P? How do we get that distance? Somebody help me. Give me that distance. Give me that distance. I want to check your physics. Can we confirm what Tina is saying? Whole thing here is 0, comma 4. Part is 0, comma 15. Plus 0, comma 25. Minus, what is K? 9 times 10 power 9 QA over. Now remember, our focus is on P, so the distance between A and P, 0.15. Guys, for the next 2 minutes or 2.5 minutes, I want you to complete that calculation for me. If you have not written this down, don't write yet. Just do the. Don't throw your answer in, please, for me. I need answers, guys. Are we struggling with the maths? Yes, but what's your own answer? As I'm waiting for answers, 1, comma 5. What do you have? 5, comma 9. Right, we are having difference in exponents now. I see what might cause that is your function calculator use. Please, I need more answers. Right, let's do it together. Look, it's very simple. Um, I would say bring all of this to the left. Q is. So 9, it becomes positive QA over a negative 9 plus, I'm taking the 6 over. What? 5. Grab a calculator quickly. Guys, in an exam, you know how to. I asked you to do it. I know that here, a lot of people get it wrong because of the expert. Please, 9 times 10 to the power 9 times 6 times squared plus, let's open a bracket there, 6 times 10 to the 5. All right, that's what I have. 6006. Fine. Mama? Oh, yeah, okay, I'll square that. Yep. 1.15 squared. Okay. But so far, we're still good. That would not even affect my answer for now. All right, but thank you. 600. I have 600. That is squared. All right, so what do we have? 9 times 10 to the power 9 over 0.15 squared equals to, depends on your maths. You can cross multiply. But 600,864 times 0.15 squared. And then you can divide both sides. Please use button, not use this numerator denominator fraction button, please. Squared 864 times 0.15 squared, everything divided by, that goes. Please, once you start using the normal grade 8 division, that line with 2 dots, we are right. 1.50 times the steps. What's your phone? Guys, take note, screenshot. We need to run quickly so that we save time. Right, I hope it makes sense, guys. Please, no room for errors when we do calculations. All right, so Google, those were your questions. I hope. Lovely questions, though. Thank you. I have a more interesting one for you guys. One more electrostatic question. I'll give you 6 minutes to quickly get this done. Read carefully. This is Let me know if you're done. Just say done so we save time. If you're done, please let me know. All right, Google done. Only one person done. Come on, guys. You have 30 seconds. Okay, we are getting done. All right, let's quickly read through. Okay, three metal spheres X, Y, and Z are mounted on insulated stands as shown. X carries a charge of positive 20, Y negative 8, and Z is neutral. Give a reason why the metal spheres are mounted on stands. Why are they mounted on insulated stands? And the loss of charges, to prevent the loss. That's a common grade 11 question. Loss of charges by leakage. Number two, sphere X is brought into contact with Y, all right? Sphere X is brought in contact with Y, where X is moved, then brought in contact with Z, okay? Sphere S is first, let's look at the English there, first brought with Y, then moved to be in contact with X. Calculate the net charge on each sphere after they are separated. X first on Y, then X with Z. Okay, so X is positive 20, Y is negative 8. X positive 20 times 10 to the power negative 9 columns. Y is negative 8. All right, what is the Q new? What's the formula? 1 plus Q2, 20 times 10 to the power negative 9 plus 8 times 10 to the power negative 9 over 12 divided by 2. Positive power negative 9. This is y. Now q, x and z, rather, x and y, then x and z. Our new x is positive 6, the power negative 9. But z is neutral, 0. Therefore, is positive 3 times 10. Let's write all the charges out. When charges are brought together and separated, that's what we get. So our qx new are negative 9 columns. Y new is positive 6 times 10. Z new positive 3 times 10 are negative 9. When charges are brought together and separated, we add the charges and divide them by the number of charges. Are we okay? Are we okay there? Important. Now, if you notice, we've got x, we have y, and we have z. This one was positive 20 and negative 8. When we brought the two together, how will electrons move? Electrons would move from where they are more to where they are less. Where are they more? They are more in Y. Electrons are negatively charged. Electrons would flow from Y to what? X. Now, our new X became positive 6. Z is 0. Where will electrons move from? I'm tempted to say 6. No. Electrons will move from more electrons in Z than X. Because the electrons are negatively charged. Basically, X gains what? Mass. Gain of electron. In grade 12, you would see that electron also has a mass. Although it's very small, but it does have a mass. Very small, tiny little thing there. It's 0. 1 times 10 to the power negative 31, but it does have a mass. Right, please, let's get that. Okay. Now let's look at the next set of questions. I love this one. I love this one. Time will not allow me. I wanted you to try. 3-point charges X, Y, and Z of magnitude positive 20, negative 5, and positive 30. Micro. Please let's understand the units as well. Micro is times 10 to the power negative 6. Nano times 10 to the power negative 9. Pico to the power negative 12. Milli. This standard notations will not change. Please let's know them. Let's know them. Centimeters to meters, Centimeter over 100 would give you meters. Meters over 1,000. Standard unit of distance is meter. That the main conversions that, right, we are told they form a right angle. 7.3.1, I would leave you to go and get the definition. The magnitude of the electrostatic force between two charges is directly proportional to the and inversely proportional square of the distance. That we are not negotiating. Calculate the magnitude of the net. I mentioned something earlier on. Anytime you see the word net, start with a free body diagram. Now, net on which one? Net that is exerted on Y. So our focus is what? Y. So let's go and draw a free body for Y. There we go. Y. Now, let's compare Y and X. What's happening? We are focused on what? Y. So, where should the force be from that is acting on Y? Or in short, where should Y want to go? Up. Y side. X is on top there, it's positive. Y is negative. It's attraction. So where would Y go? Towards X, because it's attracted towards. Right? We are looking for electric force. So F, since it's F between X and Y. Now we go to Z. Y and Z. Z is positive, Y is negative. Y will be attracted towards Z because they are both opposite what? Charges. So what will this be? F of Z on Y. Once you see a 90 degrees, guys, what we use 10 parallelogram of forces. Diagram there. And then we draw our result. That becomes our resultant force. F net. Since it's a 90 degrees, we can, let me draw what we have out. This is now what we say. F net, we have one horizontal, and we have, right. So this is F net, this is FZY. 90 degrees. So what do we have? F net squared theorem of what? Pythagoras. And we know F as what? K, Q1, R squared. We use the theorem of Pythagoras there to find our answer. But we need to get fxy first, fzy. Okay? I'm going to just, guys, I want to finish the calculation. I'll just substitute. We would go out. So f net squared will be equal to k q, the what? Between x and y. Qx qy over r squared plus k qy qz over, this is the distance between x and y, this is the distance between y and Z. All right, I'm sure, guys, we can figure this out. The square root of 9 times 10 to the power 9, what is QX? We're not using the signs anymore, guys. 20 times 10 to the power what? Negative 6. What is QY? 45. And then the other one is 30. 45 times 10 to the power negative 6 over, I'll fix that distance. Okay, I'll fix the distance. All right, plus 9 times 10 to the power 9. QY is 45 times 10 to the power negative 6. 30 times 10 to the power negative 6 over. Now, RXY, the distance between X and Y, 600. Dividing by 1,000. 1, 0, 8. I will not allow. Let me finish this page and then you take a picture. Charge Y is now removed. Define electric field at a point. Was experienced per a unit. Calculate the magnitude of the what? Net electric field at the original position of Y. Net electric field. You can do the whole thing again, but that's going to be a waste of time. But you can walk through again if you want to walk through. Just F over what? Q. If I use E net, I must bring in what? Whatever answer I get, I must put there. What is Q? The charge at Y is 45. Negative 6. You put that in a calculator, new column. Right, you can screenshot. That today we did a linear one, right angle. But a diagram that looked like this. F, X on Y, and the examiner wants you to calculate the direction with FXY. Force is a vector quantity which has both magnitude and direction. So we use our trigonometry, that's all. SOHCAHTOA. Remember, this is a 90 degrees. So we bring in SOHCAHTOA, opposite over adjacent. Then opposite over adjacent. That's trigonometry. All right. Time. I do have. You see, I had a lot of questions, but we will not be able to. Okay. I think for the rest of us, please do send me your timetables. I've only received a few. I'm waiting for more, and that's why I quickly switched today because I received writing physics just I'll send you these questions. You need to keep working. Those of us that are still doing physics, I think it's still a few weeks. Now, we still have time. Mataiba, I'll need to work with you. So once I send you this, start doing them. Once you have time, send me your you with them. Okay. But for the rest of us, you still have time. But I'll send this on the group so that everyone can work through. All right. But right now I'm just quickly going to help Taiba because she's right. The rest of us do it. So when we meet next time, we don't waste time. We just check our answers and we will just mark as quickly as possible. Guys, is that okay? I hope this session was helpful. Our next session would look at electric circuits. We'll look at a few more questions on electrostatics, and I'll look at answer some questions on electromagnetism. Please make sure you use the web. The lesson for electromagnetism is there. All right, I didn't want to waste time doing that again. It's just a few marks. So I didn't want to waste so much time. Please just go through that lesson. It's already there. I sent the link sometime last week. Let's go through again and enjoy. All right, guys. This is where I will be signing out. So today we did electrostatics. We did Newton's laws. Some lovely, lovely questions. I'll send you the PDF once I'm done here. Okay. Just in the next 10 you'll get it. All right, guys. Good night, everybody. And have yourself a very, very warm evening. Good night. Bye, Taiba. Bye, Google. Bye, Nasaber.